Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So in today's challenge, although it is a marked hard problem, I think it's quite medium and I will show you a very simple problem to solve that for today. So let's see the question at first. Replace the non-coprime numbers in an array. You are given an array of integer nums. Perform the following steps. You can select any two adjacent numbers in nums that are non-coprime. It means that coprime numbers have their GCD or HCF to be 1. Okay, so I think you already know that coprime numbers have their greatest common divisor to be 1. So non-coprime numbers definitely means that their greatest common divisor would be greater than 1. So GCD of two numbers should be greater than 1. If no such numbers are found, stop the process. Otherwise, delete the two numbers and replace them by their LCM. Okay. Repeat this process as long as you keep finding two adjacent non-coprime numbers. You need to return the final modified array. It can be showed that the replacing any adjacent non-coprime numbers in any arbitrary order will lead to the same result, and test cases are generated so that the values in the final array are less than or equal to 1e8 and two values are non-coprime. It's just told that what is the meaning of the non-coprime numbers and what is the meaning of this GCD, this greatest common divisor of x and y. Okay, so let's try to understand this example for instance. Okay, so 6432762. So let's see. So we have the array 6432762, 6432762, right? So let's try to check these two numbers first. So if their GCD is 2, so I hope you already know that the GCD of 6 and 4 is nothing but 2, which is greater than 1. So we can replace them by their LCM, right? Then the LCM of 6 and 4 is 12. I hope I don't have to explain you these simple things because these are very basic maths. Okay, so 12 3 2 7 6 2. Okay, so I hope you do understand that now the GCD of 12 and 3 is also 3. So you can replace it by their LCM, which is 12 12 2 7 6 2, and so on. You can go, right? So you see that 12 and 2, again you can replace them by their LCM, which is 12 7 6 2. Now if you try to see 12 and 7, these two numbers have their GCD as 1 because they do not have any common factor, right, apart from 1. So I hope you do understand that they cannot be reduced, and 7 and 6 also, if you see, their GCD is 1, and 6 and 2, if you try to see, their GCD will be 2. So you can replace them by their HCF. Okay, you can replace them by their LCM. So you can write it something like 12 7 6. So this will be your final array because definitely no more options you get. Okay, so definitely you see one thing is that in any order you can reduce. So you can definitely start reducing from left. This is your first observation, reducing from left greedily. Okay, but if you try to do this in a brute force manner, it will result in a TLE, because if you see, you understand that these two are the two adjacent numbers which has a GCD of greater than 1, but then you see that if you try to replace it by 12, then you will need to shift every number by left. Okay, so what do I mean to say is that you are deleting two numbers. First you will delete two numbers, right? So when you delete two numbers, this number will become the first number, and therefore you will need to shift this number by left in two places. Okay, so that will cause a TLE because in every operation you are using this O of n times, and you are using n operations, which will lead to an O of n square time complexity. That's the thing where it will get an error. But since you get the hint that reducing from left greedily is can give you an optimal answer, can give you the final array. So what you can do is that you can simply choose to use a stack. Choose stack. Why? Because now you do not want to you do not want to shift all the elements whenever you see. Okay, so what you can do is that you can keep an element. Okay, you can keep the first element. So for every element you can go through all the elements. Okay, you can go through all the elements in this array, and while stack is not empty, you can just have that while stack dot empty is not true. What you can do here, you can simply and you must also see that while stack dot empty is not true, and also the GCD of this number. So you can have a number, GCD of this number, and whatever the stack dot top element is greater than 1, then only you continue with this while loop, and every time you can just replace this num by the LCM of num and stack dot top. I hope you do get it. What I am trying to say is that I am doing the exact same thing, right? I am doing the exact same thing. If you try to see, if you try to make a dry run of this same code again using this stack, I hope you will get it more clear. Okay, 6432762. So I will just do it again. I will try to dry run this. 6432762. So let's say I have a stack. Okay, so first of all I have a stack with me. Okay, so first I will push this 6 into my stack. Now I will see that whether my stack is empty. Okay, if at first I will find my stack is empty and I will simply push 6. Then I will go to push 4. When I am pushing 4, I will check that the stack dot top element and my current element, these two GCD is greater than 1 or not. Okay, so while these two GCD is greater than 1, I will keep iterating. So that means in this while loop, and if it is greater than 1, I can simply replace, right, and I can do a stack dot pop here also. So what I will do, that if my GCD of 6 and 4 I found it to be greater than uh, 1, so what I do is that I will just pop this 6 out and replace this by their LCM. So LCM of 6 and 4 is now 12. Okay, and I hope you do understand. Okay, so as I replaced it, now I can go to the next element. So now I will see that my LCM is 12 and there is no more element after reducing 6. Okay, after deleting 6 there is no more element, so I will just simply push this 12. Okay, then I will again try to take this 3 and again find this, pop this 12 out and again store the LCM as 12, and then I will again find that there is no element in the stack, so I can simply push the 12 again. So now I am at this 2. Again the same thing will happen. I hope you do understand what is happening. Exact same thing will happen, is that 12 will only be remaining in the stack in a very similar manner. Now you try to push 7. Okay, whenever you try to push 7, you see that in the while loop only, in the while condition only, you will see that these two GCD are equal to 1. So you cannot push, you cannot enter inside the while loop only. So outside the while loop you just do a push. Okay, so outside of the while loop you can just do a stack dot push num. Okay, so this num you are updating to LCM, so you can just do stack dot push num. So it means that now, right now, since these two GCD is equal to 1, now I have 12 and 7 in my stack. Okay, now since I have 12 and 7, what do I want to do is that I want to check my next number. What is my next number? My next number is 6. So I will just check 6 again. I will just check for 6 again. I will check that the stack dot top and this 6 GCD is 1. So I definitely can't push it again. So now my stack will contain something like 12, 6, 7. Now if I try to see the next number, if I just try to see the next number, I will be having something like 2. Now 2 will definitely be having a GCD of greater than 1 with 6, okay, with the top element, and definitely we can replace 6 first, and then LCM of 2 and 6 is again 6. So I will just replace 12, 7, 6, and definitely my final array will be, I will take the elements from the bottom because this is a stack and store my final answer as something like 12, 7, 6. You see that essentially I am doing the same thing, I am doing the exact same thing which I showed you initially, but in order not with an array but with a stack, because of this movement, because of this shifting after deletion. In stack you can conveniently delete. Okay, so I hope you do get what I am trying to say, how this stack approach is working. So yeah, that's all. You can just try to code it now on your own also. I guess you will be able to code it right now. Okay, so let's see. We will have a stack definitely, as I have been telling you. So for every number I will just go through every number in n, and at first I will initialize some number which is nothing but nums of I. Okay, so what I will do in this number is that while not of stack dot empty. So I will see while stack is not empty, and I will also say that while this number while the GCD of this number and this stack dot top, okay, if the GCD is greater than 1, okay, if the GCD is greater than 1, then I can do something. I can take the LCM and pop it. Otherwise, at the end, I can simply, I mean, after I have been done all operations, or if it is, I cannot enter the loop, in both of the cases, I will just push an element every time. Okay, I will just push this num element every time into my stack. And what will happen inside this while loop is that I can simply calculate the LCM, right? So I can do something like number equals to LCM of number comma stack dot top. So I hope this I need to do before deleting the element from stack, otherwise we will lose information, right? So we can just delete the element right now, and that will be all, I guess. So what will you store in your answer? Tell me what you should store in your answer. You should start storing elements from the bottom, right? So stack dot size will be the size of your array, and what you can do, you can have an index which will initially point to, let's say, stack dot size -1. Okay, so it's pointing to the last element of the answer, because we need to start fill the answer array from the last element. Okay, so also what you can do is that while stack is not empty, you can just keep iterating through the stack, right? So while stack is not empty, you will do something like stack dot answer of index equal to this stack dot top, okay, and stack dot pop. Also you can reduce this index, okay, also you can reduce this index and simply return this answer. So definitely we need to implement my GCD and LCM function, which I have been using in both of these cases. Okay, so you can look their implementation, look after the implementation in the net, I guess. GCD by long division method you must have done in your primary classes, right? Finding the HCF of two number using a long division method. So what I can do is that I can look to return something like, in a recursive manner, GCD of y and remainder after I keep on dividing x by y, and if I get a remainder which is 0, so if y is 0, I will just simply return x. Okay, I will just simply return x. That is how you can calculate GCD. This is a simple long division method of calculating GCD which we used to do in our childhood. Okay, I hope you remember it. If you don't, you just Google that out. Okay, so also LCM, you know that the product of two numbers is also equals to the product of GCD into LCM. So LCM we can easily find, right? So I hope you know all these things. Let's say the product of two numbers A and B is always equal to LCM of A and B into GCD of A and B. So if you try to find only the LCM of A and B I need to find right now, right? So you can simply do nothing like A into B by GCD of AB. Okay, GCD of A comma B. So that's what you can do to find the LCM. So you can directly return some value, right? What do you need to return? X into y divided by GCD of xy. Okay, I hope you do understand, but this might sometimes cause an issue because x and y can be up to 1e8, so just turn it to long for safety reasons. So yeah, you can try this out. I guess this will give a good runtime complexity also if you try to run it and check. This I am using n, but I do not have n, so I can just do num.size, right? Let's see if there is any error I did. So we did get the accepted thing. If we try to submit it and check for all test cases, and what will be our percentage bits for this? You see we are getting a very good memory complexity, and runtime is not that good, but it is okayish. I was getting a 90% runtime even with this exact same code. So yeah, I mean, you can just try it out. I don't know why exactly this is giving a less runtime complexity right now, but yeah, it varies, and I hope you do understand my method, how is it working. And yeah, I hope if you have any doubt, you can definitely ask me in the comment section. I will say that this is not at all a hard problem once you figure out that you cannot do this whole thing in an array and you just need a stack for this. So yeah, that's all for this video, and I hope you have a really easy day ahead. Thank you so much.